Good morning, everyone. Myself, I'm Tanishka from Triple E Department from Section A. Today, I'm going to discuss the topic about simply inverted matrices, course title from matrices and calculus. Simply inverted matrices, understanding matrices inversion. A critical component in linear algebra matrices inversion provides a powerful tool for solving complex systems of equations. This presentation explores what an inverse matrix, why is it necessary, and how to compute it, starting with the simple 2x2 examples. The identity matrix, the matrix 1. The identity matrix plays the same role in the matrix multiplication as the number 1 does in the scalar. It must be in square matrix n into n. The main diagonal element, top left to the bottom right, are all 1s. All other elements outside the main diagonal are zeros. For the matrix A is equals to delta A is equals to delta A is equals to A. Example 2x2 identity matrix. There are the examples shown here for 2x2 identity matrix and 3x3 identity matrix. Why do we need the inverse matrix? Firstly, to enable the matrix division. Since the matrix division is not defined, we use multiplication by the inverse matrix to achieve the same results. Secondly, to solving the matrix equation, consider the equation Ax is equals to B. To isolate the unknown matrix X, we pre-multiply both sides by A into -1. This cancels out A and allows us to find X. Third one, applications in modeling. Inverses are crucial for solving real-world problems and for such as network analysis, optimization problems, and curve fitting in data science. Examples for inverse of 2x2 matrix are first, define the matrix. Given matrix is shown below. And second, to calculate the determinant, first find det A. Here for the given matrix, the det A should be multiplied by the first number by the last number in the 2x2 matrix. For example, 4 into 6 minus 7 into 2. That multiplies and gives the value 24. Third step, to calculate the inverse using the formula A inverse is equals to 1 by 10 by the matrix. Result in the inverse matrix is shown here. Inverse of the larger matrices. First, construct the augmented matrix. Second, apply row operations. Third, identify the inverse. Properties of the inverse matrix is first, inverse of the inverse. You can see the formulas over here. A into -1 into -1 is equals to delta A. Second one, inverse of the products, reverse order. AB into -1 is equals to B multiplied into -1 into A multiplied into -1. Existence condition, delta A, order of multiplication, A delta A into -1 into A is equals to A into -1 into delta. Real world application, solving system of equation. You can see the below, they are given the solving method and the scenarios for the equation 1 and equation 2 and the solving methods over here. The matrix formulation Ax is equals to B. The summary. Reciprocal in the matrix form. The inverse matrix A into -1 is the generation of the scalar reciprocal. Second, the fundamental problem solver is the given formula x is equals to A into -1 into B. Determinant is the gatekeeper. Existence of an inverse is strictly conditional. Only square matrices with a non-zero determinant possesses an inverse, which is crucial point to remember in all calculations. Thank you.